All right, class. For Group 7's manufacturing process, we're going to be talking about extrusion. Now, in the presentation, we're going to be talking about various types of extrusion processes, as well as showing you different videos of it. Our group consists of Gabriel Silva Solis, Timothy Tang, Calvin Wong, Roberto Zuninga, and myself as Andy Daniel Zabeta. Now, our first video we'll be talking about is direct extrusion. The video is provided to us by Linear, and they're basically a manufacturing and distributing company that focuses on plain bearings, linear guides, and custom machine parts. The video itself is going to be focusing on an aluminum extrusion machining process. Now, the first step is prepping or inserting the die. The die itself will create the shape or profile of the final extrusion. Uh, and it's important to preheat the die itself to prevent material from sticking to the openings. Now, of course, there are different kinds of die with various shapes or various openings, and each one will produce a different kind of final profile. The one on the left creates more of like hollow areas within its cross section, while the one on the right is a solid piece, but still pretty unique. Second is prepping the billet. Now, billets can range up to like 3 feet long, and in this video, it's being preheated in a heating oven. I believe it's heated up to 900 degrees Fahrenheit. What makes this important is that although it will lower its strength, it will increase its ductility. Also, by heating the billet, it allows more extreme size reductions and complex shapes to occur. And although its color hasn't changed as it's exiting the heating oven, it's still extremely hot. What comes next is loading the billet onto the container. What's pushing it inside the container is the ram along with its dummy block. And it pushes it until it comes in contact with the die. And as pressure increases, the aluminum is forced through the die opening and comes out as a fully formed profile. Now, if we look at the reference image in front of us, we can see what's happening more or less inside the container. It's important that the dummy block itself has a smaller cross section than the billet. And this is to basically keep the oxidized layer that's occurring inside the container to stay in there along its walls. And so whatever is being extruded out will be free of that. What comes next as it's forming its final like cross section is that the aluminum is being pulled and then it's actually being cooled naturally as well. Either by room temperature. It can also be this process can also be sped up if it's air quenched or water quenched. And what's important about this is that it will ensure any metallurgical properties remain after it's aged.
Once the extruded profile is cooled by room temperature air or water quenches, it is moved to a cooling table where a stretcher stretches it, and it is then taken to a commercial saw to be cut to commercial size. At the cooling table, it's given further time to cool down until it's cool enough to be worked on. A stretcher machine is then brought to stretch out the extruded profile to help correct any bends or twists that occurred during the extrusion process. Once that is done, it's taken to an industrial saw. At the industrial saw, it's cut to commercial size and racked and prepared for the aging process. The aging process is very important because it drives the extrusion alloy to its optimal strength. The aging process is also known as age hardening. There are two types: natural aging and artificial aging. Natural aging occurs on a rack at room temperature over long periods of time. Artificial aging is performed in an aging oven. In these aging ovens, these extrusion alloys are exposed to controlled heat treatments. The oven further strengthens and hardens the extrusion profile. It's done by controlled thermal heat treatment. This heat treatment affects the extrusion alloy's structure in a way that maximizes its strength, hardness, and elasticity. Finally, we go back to the machine and we remove the die. The die is then cleaned and prepared for the next time that this extrusion profile is needed in the factory.
Hello, my name is Calvin Wong. I'll be doing indirect extrusion. Extrusion is when instead of the billet getting rammed into the die as for direct extrusion, indirect extrusion is basically you use the die pressed into the billet. The parts you use the parts made for indirect extrusion is basically piping or tubular parts. It could be any geometry like circle, square, things like that. Um, Indirect extrusion also is known as backward extrusion. Indirect extrusion, the breakdown of the process is basically, as you can see, the green part right here, that's what the billet is. The billet is basically the aluminum or whatever material you're using to extrude your extruded parts. You have the container, which contains all the tool, the ram, the die, everything in there. So as we said before, the die is pressed into the billet. The container contains the billet inside. The die is pressed against the billet to extrude a die geometry of whatever the die was shaped as. The die can be almost any shape. The process, well, there's two types of process you can do, or there's actually a couple more, but what we're going to do now is we're going to do the solid cross section and the hollow cross section. The solid cross section is basically how you do like tubular parts. It could be a solid circular piece. As you can see in A, blue right here, that's the billet being pressed against the die. So the force is being applied through the ram, causing the die to press against the billet. So that's basically what the solid cross section does. The hollow cross section is usually used for like small piping parts, things like that. So this one's on B side. As you can see, the ram's right here, the die is right there in the diagram, and it's being pressed against the billet. As you can see, there's a hollow core, but around it, the cross section is basically like a pipe. The advantage and disadvantages of indirect extrusion is basically for the advantages, you have less friction during the process. So indirect extrusion has more friction compared to indirect extrusion. It can be used in hot and cold extrusions. The disadvantages is when you're extruding like let's say for example the hollow cross section, supporting that extruded part could be a problem. It's not as versatile compared to direct because you can make a lot more complicated shapes using direct extrusion. And one problem is you have to check the billet whenever you're using indirect extrusion because the surface of the billet itself, if it has defects, it could also ruin your extruded part. The next slide would be Tim. Pass it to him. Thank you.
Hi, my name is Timothy Tang, and I will go over cold extrusion as well as other extrusion processes in the video, such as impact extrusion and discrete processing. In this video, you can see the billet is loaded into the die. Note that this is called cold extrusion because the billet or slug is at or near room temperature during the impact extrusion process. As the punch is lowered into the die, the billet is pushed out, creating a cylindrical pipe with the thickness being the radius of the die minus the radius of the punch. This is also known as backward extrusion as the billet extends around the punch. The steps for impact extrusion are load the metal billet into the die. Next, operate the mechanical or hydraulic press to lower the punch into the die. And finally, remove the part. When compared to other extrusions, impact extrusion operates at a higher speed with shorter strokes, allowing up to 60 parts to be done in 1 minute. This allows the final piece to be high in hardness and yield strength due to strain hardening, has a good surface finish, and has tight tolerances. The impact extrusion you see in this video is considered a discrete process because one part is produced per extrusion cycle. In this part, you can see the worker applying powder to reduce sticking, which is the fusing that occurs when two metals shear rather than slip. And it also makes it easier to remove from the die. Thank you. And next, Roberto will be going over hot extrusion.
So hot extrusion is the process used to form special steel profiles with a constant longitudinal cross-section. Through hot extrusion, it is possible to obtain specific shapes by allowing the steel to flow through passageways arranged in special dies. This type of manufacturing process is the most beneficial to customers as it provides financial, technical, and environmental benefits. Next slide. Not yet. So the process of extrusion, let's play the video, is the raw material is peeled in order to obtain the required diameter. The peeled bars are cut into billets, and the raw material to be extruded needs to be heated up. The metal is then pushed through a die, and the die includes a special slot. The extrude bars are subject to finish to a process, as seen in the video here.
Thank you, everyone. That concludes our presentation. If you have any questions, please feel free to tell us at this moment. Thank you.